Our next is actually number 8, and it's on equations, inequalities, and real numbers. And this is 1.2, and the question is, for what values of x is y real? And if you look at that, the only restriction here is we have a 16 minus x squared, which is under the root sign, and that must be greater than or equal to 0, which means that x squared minus 16 must be less than or equal to 0, which means you've got x minus 4 into x plus 4 is less than or equal to 0, and I think all of you know how to solve this. X is greater than or equal to minus 4, less than or equal to 4. This problem is 2.2. You will notice it's also already given in factorized form, 3 factors less than 0, which is negative. Now if we look at the 3 critical values here, and it will give us 4 regions basically, and my advice is to use the number line, and the number line you don't have to draw it very fancifully, it's fine. Minus 2 is 1, x plus 2 will give you minus 2, 3x plus 1 will give you minus 1/3, and x minus 4 will give you 4. We've got 4 regions now, 1, 2, 3, 4 regions, and what we're basically looking at is we're looking for negative answers for the region. So I would suggest you do this. Consider x is greater than 4 and take the value 5, and you'll notice if you take 5, that would be positive, that would be positive, and that would be positive. So 3 positives will give you a positive, and that will become negative, that would be positive, that would be negative. And if you investigate this over time, you'll find it always behaves in that fashion. And we know where our negative answers are. X is less than minus 2, or the other answer is between these 2 critical values. X is greater than minus 1/3 and less than 4. 2.5 is a fractional inequality. Now you'll notice the denominator is a perfect square, and it means that it's positive, but it could be equal to 0 as well, but obviously it is undefined when it is equal to 0. And the good thing here is we can actually transpose the factor x minus 3 all squared, because it's positive and it doesn't affect the inequality sign, provided that obviously that x is not equal to 3. And here now, solving this inequality, we notice that you got 2 into x squared minus 6x plus 9 is greater than or equal to x. And when we take x to the left hand side and factorize, we get 2x minus 9 into x minus 2 is greater than or equal to 0, and we end up with x is less than or equal to 2, or x is greater than or equal to 4.5, or 9/2. Now you will notice that the 3 is in between, so we don't need to there is no need to consider that. The problem on 3.1, solve for x, and so otherwise solve for k. Now this is quite a typical problem. So when we are solving for x, we need to obviously clear all the equation of any fraction. So we'll multiply by x throughout. So for 3.1, we will get x squared minus 4x minus 12 equals 0. And then you got x minus 6 into x plus 2 equals 0, and that means x is equal to 6, or x is equal to minus 2. Now, and then you want to do the next problem, which is the root of k minus 2 is equal to 4 plus 12 over the root of k minus 2. Now you'll notice that this is same as the top. The problem is same. The only difference is the x and root of k minus 2 are same. So what we have to do, whatever answers we've got for x, we can apply it to root of k minus 2. So in other words, root of k minus 2 is equal to 6, or root of k minus 2 is equal to minus 2. Now all of us should know that the positive square root must give us a positive answer. But here we got a negative answer, so we don't worry about that. Now we need to square both sides, so we'll get k minus 2 is equal to 36, k is equal to 38. Number 5, the roots of a quadratic equation are given. Find a plus b plus c. Now what is interesting about this problem here is that now if we take the roots of a quadratic equation, x is equal to minus b plus the square root of b squared minus 4ac all over 2a. There are many other ways of working this out, and your second root would obviously be minus b minus the square root of b squared minus 4ac all over 2a. Now let us find the sum of the roots. The sum of the roots means minus b plus minus, the denominator is the same, so you got minus 2b, and if you add the positive plus that expression and minus that expression will be 0 all over 2a. So we've got actually minus b over a is the sum of the roots, and the product of the roots is x1 times x2, and that's product will be we need to multiply these two out. If you look at the numerators, it's difference of two squares, so it's minus b all squared minus b squared minus 4ac all squared over 2a. If you're finding the product, it will be 4a squared. So what you really have is the b squared minus, and if I remove square that, I'll eliminate the root sign, so I got minus b squared plus 4ac all over 4a squared. So the b squareds fall away, and then your 4's fall away, and then you will end up with c over a. So your sum of roots is that, and your product of roots is that. Now what they've actually given us, so we know if we take the sum of the roots, and we're given 5 plus root 13 over 2, and you've got 5 minus root 13 all over 2. Now your sum of roots will be 10 over 2, which is 5, and so your sum of the roots is 5, and the product of the roots is equal to, as I told you, difference of two squares, which will be 25 minus 13, which is 12. 12 divided by 4, which is 3. Now let's take this x squared, right, let us take this, so you've got your product of roots 25 minus 13 all over 4, which will give you 3. So let us take the equation ax squared plus bx plus c equals 0, and if I divide throughout by a, that's what I will get, and divide that. So you notice b over a, and we looked at b over a minus b over a as the sum of roots. So you've got x squared minus the sum of roots, so it's minus 5x, and your product of roots is c over a, which is plus 3 equals 0. And if you now look at the problem itself, it is perfect. If you look at this, it's minus 5 plus or minus the square root of b squared 25 minus 4ac 4 3 is 12 all over 2, so you will get the 2 roots. This is Mathematics of Finance, which is on page 63, and what we're basically looking at is present value of annuity, and this is normally associated with borrowing money or taking out a loan. Now, a borrower agrees to pay a loan of 25,000 rands each at 11% per annum compounded annually over 10 years. First payment is made at the end of the first year. What is the installment? Now, what we need to do is to just work from first principles. And what I want to do is to just take you through it very quickly. Let us say that we want to borrow an amount of P, and then we say to the person, we'd be able to pay you this amount at the end of the year, right? And the amount that we can pay you is X, which is like an installment. And then what would happen is, obviously, whatever you borrow will be multiplied by 1 plus I to the 1. So if I take the 1 plus I to the 1 across, it will be 1 plus I to the minus 1. So therefore, and if you want to experiment with this, it's fine. Let's assume I want to pay 1,000 rand at the end of the year, and I want to find out what can I borrow now. So what will happen is, I've got P is equal to 1,000 rands, and they charge me interest of 10%, let's say. So it's 1 plus 10% to the minus 1. And then when you work this out, you'll get 909 rands. So which means, if you borrow 909 rand at the beginning of the year, and then they charge you interest, so the 91 rand is interest that you pay, and then you could that's what they would lend you, and at the end of the year you pay 1,000 rands, then you cancel off your debt. But supposing you say, I want to borrow some money now, but I can only pay you at the end of the second year. So what will happen is, 1,000 rands, you can only pay 1,000 rand at the end of the second year. So what they're going to do is, they're going to charge you for 2 years interest. These minus 2, they represents 2 years interest. And when you work this out, it works out to 826 rands. Now what it basically means that you can borrow 826 rands. You don't have to pay it at the end of the first year. You can pay your total of 1,000 rand at the end of the second year, and you owe nothing. Right, now this leads us to the main problem. So if we are borrowing, so let's say P, and we're paying installments of 10 installments. So your first installment, X into 1 plus I to the minus 1. second installment x into 1 plus I to the minus 2, and third installment x into 1 plus I to the minus 3, and so on when you come to x into 1 plus I to the minus 10. Now, if we look at this problem here, we've got common factor of x into 1 plus I to the minus 1, and if that comes out, you'll get 1 plus I to the minus 1 plus 1 plus I to the minus 2, and the last term would be 1 plus I to the minus 9. Now, if you look at that, it is called a geometric series, and in terms of the geometric series, we can use Sn, which is a into 1 minus r to the n all over 1 minus r. Now, if you take a as 10 we got now, a is 1, we can ignore it. 1 minus r is 1 plus I to the minus 1, and we said to the n will be minus 10, all over 1 plus I to the minus 1. Now, if I go and substitute at the top there, I've got in my numerator x into 1 plus I to the minus 1 into the value that we've got here is 1 minus 1 plus I to the minus 10 all over 1 minus 1 plus I to the minus 1. Now, if I move this down to the denominator, I will get x into 1 minus 1 plus I to the minus 10 all over, and then I'm going to have 1 plus I to the positive 1 into 1 minus 1 plus I to the negative 1. And then what's going to happen is this, that you have x into 1 minus 1 plus I to the minus 10, and look very carefully at the new denominator. 1 plus I times 1 is 1 plus I, minus 1 plus I to the power 1 times 1 plus I to the minus 1 is 1 plus I to the 0, and 1 plus I to the 0 is 1. So we got 1 plus I minus 1, which is I, and that leads us, that's our formula, which is P is equal to x into 1 minus 1 plus I to the minus n all over I, and that's a present value formula. Now we still have to get back to the problem. The problem there now is saying that 25,000 rands was borrowed, so you've got P is 25,000. P is 25,000, and we want to calculate the installment x into 1 minus 1 plus I. You notice the interest rate is 11%, so 1 plus 11% is 1 comma 1, 1 comma 1, 1, and then it's over 10 years, so it's minus 10. All over 11%. That's all over 11%. And then what happens now is you want x, so you say x is equal to 25,000 times 11% all over 1 minus 1 comma 1 1 to the minus 10. Now remember that this could be a multiple choice question where these are the options that would be given. Because you're not using the calculator, they don't expect you to do that. And we will move to the next problem.